Hello, everyone. Hopefully this is coming through okay. I'm Jessica Hall. I'm the Cincinnati chapter president with Get With It, and very honored and excited to introduce Neta and Polly. And I know Polly they've sponsored this event today and wanted to talk a little bit about Ascendum and introduce Neta as well.
Well, thank you. This is Polly Anthony. I'm the head of marketing for Ascendum Solutions. Sorry, I don't have my video up today, but I just want to tell you a little bit about Ascendum and a little bit about Neta. Ascendum is basically a global technology firm, and we're dedicated to delivering pioneering ideas in custom software, UX, UI design, and data engineering solutions that enrich our clients' business operations and customer experiences. Our clients come to us for basically boundary pushing solutions and ideas. We're really pleasure to introduce Neta today. Neta is our Chief Data Officer, and she was recently this year recognized by CDO magazine as a Global Data Power Women for 2020. So we're really proud of her for that, and quite a great accomplishment. Neta has a vast experience and a deep love of pretty much everything data architecture, artificial intelligence, machine learning, DBA, BI, basically everything data engineering and data science. She is an expert in data design and implementation, and she has an emphasis on great performance. So with no further ado, it's my pleasure to introduce our CDO, Neta, who will speak on AI and ethics in the data revolution, and we're happy to sponsor the event. Thank you so much.
Thank you, Polly. Thank you, Jessica. Good afternoon, everyone. Thank you for joining us today to learn and discuss data and ethics. As Polly said, I just love everything around data. And even in my personal life, I collect data and analyze that just for fun. My car's fuel consumption, the receipt from the grocery store, and whatnot. So let's start. AI, artificial intelligence, is a powerful tool. It's present in things like self-driving cars and real-time translation of people speaking different languages, allowing communication on a level previously reserved for science fiction. Even healthcare utilized predictive AI algorithm. Almost every industry and vertical is affected by this advancement in data and technology. With the rapid pace of change and innovation in tech, the law, and more importantly, ethics, can't keep up. Lawmakers can't move as fast as tech companies or individuals doing cutting-edge research. Instead of ignoring this aspect of the development, waiting to act only when the law finally catches up, which it undoubtedly will, we can prepare for it. As a guideline, the law is usually the moral minimum. It is ethics that set the higher bar. The leap to big data happened almost overnight, bringing socioeconomic revolution, changing the way we work, live our lives, and interact with each other. It really is a revolution, and some people would say with an impact almost as significant as the agrarian revolution and the industrial revolution. Collecting, storing, processing, and analyzing the raw data required sophisticated technology. Without the rapid progress of the big data technology, it would have been impossible to gain useful insights from the data, a technique that is known as data mining. Business, governments, and other organizations are utilizing these tools and technological advancement. The changes that big data will bring are exciting to see. Data analysis tools like deep learning will become better, more accurate, more efficient, more intelligent, and more accessible. These benefits of this are many, including in the fields of ethics, but like all revolutions, the big data revolution one can have losers as well. It gave malicious people new ways to carry out their behavior and inflict harm in unintended and unforeseen ways. The basic picture of data is of bits and bytes in the memory of computers. But in general terms, data is just facts stored in one place. The data itself is neutral. It doesn't know where the facts came from, how they were collected, and how they were recorded. The concept of data isn't new. From the very early times when our ancestors had the ability to make records or facts for later use, like marking and symbols on cave walls. Data ethics is a new field that arose following the big data revolution. studying the ethical implication of data. Ethics have been an important topic discussed since ancient times, with Western ethics springing from the Greeks and Romans. And even without adding data into the mix, ethics is a complex field with many different theories and principles. Some of these different views on ethics can be contradicting, and trying to compare them can get challenging. Entire conferences are devoted to ethical debate, people spending a lot of time arguing over the best ethical theories. Ethics is a rich and complex field, especially with regards to abstract ethical values. We won't go into that here, but instead we'll focus on the concrete day-to-day impact of ethics. What does it mean to be an ethical person? An ethical person is one who has an ethical concern. An ethical concern is simple, a concern with human well-being. Hence, an ethical person is one who cares about the well-being of people. As simple as that. Just a little bit of ethical theory to set the base for further discussion of ethics in data. We said that ethics is about the concern for the well-being of people. This can be broadly separated into two different groups, other people and myself. The well-being of other people and my own well-being. These translate into two sets of ethical values. One set that's based on the well-being of others, and another set that's based on my own well-being. Even without delving into the theories and the principles they come from, we can intuitively understand these values. Let's start from the first set of values, the values based on the well-being of other people. A question that needs answering first is, why should I care about a person? What makes a person or people in general morally valuable? One aspect of a person's moral value is that people are capable of suffering. They can feel pain, both physical and emotional, as well as any other form of pain and suffering. I should care about other people because my actions might cause them suffering. I need to think about the consequences of my actions before I act them out. Furthermore, people have autonomy. Autonomy means that people are capable of controlling their own actions, making their own plans and following them, and just living their lives the way they want to. Of course, autonomy has its limits, but knowing that other people have autonomy in their actions and they can control themselves, decide what to do when faced with external situations, and then do things the way they want to do them, all of this together means that I have to respect their autonomy. It would be wrong of me to use other people without consideration, as these people already have their own agenda rising out of their autonomy. Finally, equality. Equality is an important reason that I should care about and respect other people. I'm neither superior nor inferior to them, and they are not superior or inferior to me. We are all morally equal, and when I act, I have to respect that equality between us. Now to the other set of values, the values based on my own well-being. These values are about making my life go well for me. In the ethical literature, one of these values is called character excellence or virtue. Character excellence means that a part of being a good and ethical person is having a certain kind of character. Another value based on my own well-being is trust. Trust is a trust in the environment. When the trust is high, my life can go well and my well-being increases. If there is no trust in the environment, either in the case of you not being able to trust the environment you live in, such as a lawless society, or the environment doesn't have trust in you, such as a case where you have a reputation of a liar, your life won't be as good and your well-being decreases. Now let's tie in ethics with data ethics. At its core, ethics is the study of human well-being. Data ethics, then, is the study of the impact data has on human well-being. As we're all probably familiar with, data, especially big data, have a lot of positive impacts on human well-being. Sadly, there is also a lot of negative impact, or at least the potential for a negative impact on the well-being of people. Data is collected, stored, processed, visualized, and used in decision-making. And in each of these 5 steps, people's well-being is affected. The impact can be either positive or negative, and it might even be both. And it can affect individual people, but also groups, such as customers or employees, entire businesses, as well as society and citizens as a whole. All of these dimensions of data and big data and all of the potential groups that can be affected in different ways from those dimensions of the data lead to complex interactions. When these interactions impact or have the potential of impacting human well-being, ethics must be considered. As the old saying goes, there are lies, damn lies, and statistics. This is because lying with statistics, with numbers and graphs, is even easier than lying with words in speech or text. Typically, when people see graphs and charts and raw numbers, their brain tends to shut down and they accept statistics without question. This is in contrast to most data and statistic people who think that number and graphs speaks from themselves and are unfiltered and objective. Some might even consider statistics to be ambiguous. Sadly, this is a dangerous assumption to make when presenting data. Data is very easy to misunderstand, even if the data is presented in the best possible way. And with the purest intentions, this gets worse when data is misrepresented entirely unintentionally, which is the most common case, or intentionally, typically to favor a certain conclusion from the data. In fact, numbers and graphs might be the perfect tools to manipulate someone. If your goals are unscrupulous, there are various reasons that can cause data to be misinterpreted. The data could have been sampled in an incorrect way, typically not being properly randomized or sampling being biased, which is a very typical of campus studies, which are biased for young, educated, and money-strapped test subjects. These and other are collection problems. The data could also be incorrectly presented, misleading proportion of the data on a graph, confusing legends and colors, and other issues. These are visualization problems. But even if the data is collected and visualized correctly, a person might overlook the units of measurement, such as not noticing that one graph shows in 1,000 and another one in millions. These would be interpretation problems. This is an old chart from March earlier this year when the pandemic hit the Americas. It's from a news channel in Argentina. And for those who don't read Spanish, it shows the number of COVID-19 tests per million of people. We can see Argentina bar in different color on the graph, and EEUU, that's the US, and we have Italy, Germany, and Norway as well. Now, in a first glance, it looks okay, like Argentina is like the US. So if we, remember, this is from an Argentinian news channel, are doing like US or Germany, which are Western countries, we're okay. But if you look on the y-axis, especially on the proportion, something is off. I mean, if this is 258 and this is 330 and EEUU US is 7,000, something is off of the proportion. This is how the graph would look like if the proportion were normal. Still think Argentina is doing okay? Another example for May, from the state of Georgia, Department of Public Health. The chart below represents the most impacted counties over the past 15 days and the number of cases over time. Hey, Georgia, you're doing great. See how the trend goes? I mean, you managed to control COVID-19 spread. But wait, let's look closely at the axis, the dates. April 28th, April 27th, maybe it's descending, but then we have April 29th, May 1st. What's going on? Oh, it's ordered by the number of cases, not over time. A little bit misleading, no? This was not their intention, and they released this message about it. The x-axis was set up that way to show descending values to more easily demonstrate peak values and countings of those dates. Our mission fails, we apologize, it is fixed. Another examples just from the latest days. The Benfords Law is a statistical rules that says that the distribution of digits in real-world numerical datasets tends to follow a specific pattern. It is often used to test whether an election is legitimate or phony by comparing the frequency of digits in candidates' vote counts to the expected pattern. Several right-wing sources claim that President-elect Joe Biden's vote counts in the 2020 election violate Benfords Law. But if you look closely on the y-axis scales are different. I mean, narrow vertical scales make changes look larger, while wide vertical scales smooth out changes. Biden's graph is using more narrow scale than Trump's. put them all together in one graph with the same scale, and they don't look so different anymore. With the advent of machine learning, data is more and more being processed by computers' algorithms. This highlights a new source of subjectivity in the data. Before data can be processed by the algorithm, it needs to be pre-processed and cleaned up. The common way to handle the pre-processing and cleanup is an ETL, extraction, transformation, and loading. The need for an ETL stems from the fact that most data sets a data scientist uses can't be used by a machine learning algorithm as is. In fact, the pre-processing step can be one of the most time-consuming steps in the job of the data scientist. The difficulty with pre-processing data is that almost all large data sets have issues in the data. Missing values, duplicate values, corrupted entries, outliers, entry errors, and other inconsistencies. Although the pre-processing is typically run by a computer, deciding how to clean every particular case of data issue is decided by the data scientist using the data. The data pre-processing and cleanup will inherently change the data, and this impacts the subjectivity of the original data further. Even if the original data set was created in the best possible, deciding how to clean the data is a very opinionated process where the data scientist needs to choose how to handle each issue in the data, giving way to one way of handling over another. Sometimes it may even be a choice between different variables, choosing which one to trust when they have similar but conflicting meaning. The loss of the objectivity is further increasing when the data is interpreted by the audience. This is especially true when most people take the data shown to them as gospel, turning off their brains, but this is the exact opposite of what they should do. Data requires critical thinking to gain the right answers from it. Although data itself should be objective, the meaning of data is much more than impersonal bits and bytes. Data, especially big data, is often about people and the society they live in. We need to examine the interactions between individuals, the society, and the data that is collected from them. One of the most important topics to discuss here is bias. Bias exists in individuals, but there is also a societal element to it. Bias at a societal level impacts what kind of a society we live in. A place where bias seems to be considered is in predictive algorithm. These algorithms can be used to predict people's future behavior based on past action. They use large amount of data that's collected and aggregated over a lot of individuals. Statistical models are then applied to the data so that given a certain set of past behavior, they can predict what will happen in the future. As an example, consider a predictive algorithm that determines the likelihood of a person that committed a crime in the past to commit crimes again. Could this algorithm be used to determine who should remain in jail longer? At first blush, this sounds great. We're taking the bias of people out of the equation, but using a computer algorithm to determine this tough question, bias in this case is very apparent. Studies have shown that judges, juries, and other members of the judicial and penal system are biased. So it might be a great candidate to use technology to remove the bias. However, it is extremely important to understand that this hasn't eliminated bias entirely. It would be correct to say we've moved the bias from one place to another, from a human bias to a machine bias. Falling into the trap of we solved human bias by using data is dangerous and is the wrong way of thinking about bias and data. A silver lining of the machine bias is that in contrast to human bias, which comes in a wide variety of forms and sources, machine bias is a fairly consistent issue. The challenge for the data scientist is realizing that despite reducing or even eliminating human bias, we now have a new bias to be aware of. The machine bias must be addressed. Contrasting human bias and machine bias shows that although there are many differences between the two, there are some surprising number of similarities between them. Some of the similarities are fairly striking. Although we're focusing on machine bias here, we'll review human bias to give a more relatable starting point for further discussion. Understanding human bias will help us think about the issue of machine bias in data. Human bias is broadly separated into conscious and unconscious bias. This is similar to explicit and implicit bias that you may have heard about, but using conscious and unconscious is more descriptive and will be used here. For a bias to be conscious, the biased individual needs to be aware of this. A male hiring manager who is sure women are worse employees than men will prefer a man over a woman when hiring for a position. An unconscious bias, on the other hand, is one that the biased individual is not aware of. It might even be that the individual strongly and sincerely believes he is not biased. However, this doesn't make the bias any less real or have any less impact. This causes the unconscious bias to interfere with decision making, with that person not even realizing that it happened. An equivalent of conscious bias in machine bias is typically due to the conscious manipulation of the model. To continue our example, a male data scientist might intentionally alter a hiring selection algorithm to favor men candidates and disadvantage women candidates. This would be obviously highly unethical and quite likely illegal and must be rooted out. The equivalent of the human unconscious bias in machine bias is our focus here. Typically, human unconscious bias slips into our mind over time without us noticing it, building the bias subtly rather than dramatically. Hence, we won't be even aware of the impact of the unconscious bias on our assumptions and perception of other people. For an unconscious machine bias can slip in the same way from the data and the data processing, and the same way as human unconscious bias, the machine unconscious bias arises without us noticing it. There are two main ways machine unconscious bias can occur. Firstly, for the data that is provided for the machine learner. The algorithm bases the decision rules it has learned from the data used to train it. It will identify patterns in the data and create the decision rules from those patterns. Modern machine learning algorithms are very good at identifying patterns, so these patterns will probably be very accurate. However, if the data contains bias due to whatever reason, the patterns learned will reflect that bias. The biased data has introduced an unconscious bias to the machine algorithm. This may sound like an hypothetical discussion, but we'll soon see that this is very much not the case. Machine bias of this sort is just another example of the familiar garbage in, garbage out phrase. What can the machine learning learn if it's provided with biased data? This would be the same as teaching children from a biased textbooks, showing them movies that depict racial bias, and talk with them in biased language. Would a child fare better than the machine in this case? The other way machine bias can happen is during the data processing. The machine learning algorithm can acquire a bias not only from biased data, but from the way it looks at the data. Paying attention to the wrong might introduce another set of biases. A machine learning algorithm treats the input data as a host of variables. Naturally, not all variables that could be collected in the data source will be used by the machine learning algorithm, both due to the amount of data that would need to be processed, but also due to the varying degree of importance of each variable. A typical data processing step is to choose the variables that would be used by the machine learning algorithm for training. This is called the feature selection. It is important to remember that people perform the feature selection, adding their own unconscious bias to the machine learning algorithm. For example, selecting a zip code as a variable that would be included in the machine learning may sound innocent enough, but where you live might be correlated to your race, causing the zip code variable to be a proxy for race for the machine learning. This might only make the machine learning patterns biased, but could also make it downrun races. From the perspective of the machine, there is no difference if the racial bias was introduced intentionally by an unscrupulous data scientist or unintentionally through some unconscious bias of the data or the data processing. The impact of the bias on the algorithm is the same. The main problem with this sort of bias introduced by a bias in the data or by a bias in the feature selection is that it is often invisible. And similar to human unconscious bias, the invisible machine bias has the potential to be much more harmful. We could all agree that bias is a bad thing. Conscious bias is typically more visible and explicit, making it easier target to address. Unconscious bias, whether in a person or a machine, is much more harder to identify and to address. This is an important point, as AI systems are often lauded as taking the human bias out of the decision-making process. Realizing that this is rarely the case might be disappointing, but this is the first step of understanding the problem and starting on a path to correct and avoid them. An example for that would be COMPAS, Correctional Offender Management Profiling for Alternative Sanctions. COMPAS has been used to forecast which criminals are most likely to reoffend. Guided by this risk assessment, judges in courtrooms for the United States would generate a conclusion on the future of defendant and convicts, determining everything from bail amounts to sentences. The software estimates how likely a defendant is to reoffend based on his or her response to 147 survey questions. You would hear someone say something like, "See how great this predictive algorithm is? Now we don't have to worry about a jury or lawyers or a judge with bias in their hearts. An objective machine will do the job for us." And while it's certainly true that the algorithms don't have the same temptation as humans, it's very important to realize that we have not solved the problem of bias. A much better way to think about this is that we have substituted one kind of bias problem for another. And even when or if it turns out that machines are less biased, or even when and if it turns out to be true that it is easier to fix machine bias than a human bias, the fight against bias must continue. It just has a new level of complexity. And for COMPAS, studies found that Blacks are almost twice as likely as whites to be labeled a higher risk, but not actually to reoffend, where COMPAS makes the opposite mistake among whites. They are much more likely than Blacks to be labeled lower risk, but to go on to commit other crimes. TAI. TAI was an AI chatbot, stands for Thinking About You. TAI was released by Microsoft on Twitter in 2016 and was designed to mimic the language patterns of a 19-year-old American girl and to learn from interacting with human users of Twitter. Within 16 hours of its release, TAI tweeted more than 96,000 times, and Microsoft suspended the account. In 2018, MIT published a study of machine morals. The largest ever survey of machine ethics finds that many of the moral principles that guide a driver's decision vary by country. For example, in a scenario in which some combination of pedestrian and passenger will die in a collision, people from relatively prosperous countries with strong institutions were less likely to spare a pedestrian who stepped into traffic illegally. One of the co-authors of the study said, "People who think about machine ethics make it sound like you can come up with a perfect set of rules for robots. And what we show in the study with data is that there are no universal rules." The survey, called the Moral Machine, laid out 13 scenarios in which someone's death was inevitable. Respondents were asked to choose who to spare in the situation that avoided a mix of variables, young or old, rich or poor, more people or fewer. People rarely encountered such stark moral dilemmas, and some critics question whether the scenarios posted in the quiz are relevant to the ethical and practical questions running driverless cars. But the study's authors say that the scenarios stand in for the subtle moral decision that drivers make every day. They argue that the findings reveal cultural nuances that governments and makers of self-driving cars must take into account if they want the vehicles to gain public acceptance. This is the difference. For a human, it's a reaction. For a driverless car, for the computer, it's a decision that was based on a set of rules for a given data. According to the Consumer Financial Protection Bureau, as many as 11% of US consumers are credit invisible. This means that the algorithm that calculates a person's credit score don't have enough up-to-date data for that person to determine the credit score. This has a significant impact on the ability of the person to access credit. Using data analytics on new data inputs can help reduce the number of people ineligible for credit. This can include non-reported bill payments, such as phone bills, as well as data from public records, level of education, and social media. This can increase the approval rates of these kind of invisible persons when applying for credit or loan. This is especially important in helping minority groups such as African Americans and Latinos, who are more likely to be credit invisible than white individuals. Care must be taken, however, to make sure any scoring algorithm don't inadvertently perpetuate or mask bias and discrimination. As we just discussed, we must take care of both the data that is used as input to the algorithm, making sure it is accurate and unbiased, as well as how the algorithm is defined and designed to avoid bias in the decision of the algorithm. When measuring the creditworthiness of people in novel ways, it is important to develop the algorithm while being on guard against introducing machine bias into them during the design validation. An especially important example is using data that might be proxy to race, gender, or disability, such as the aforementioned zip code information, characteristic that not only may lead to bias, but also legally protected by the federal statutory law, such as the Fair Credit Reporting Act and the Equal Credit Opportunity Act. It is important to keep in mind that data scientists might not have the experience working in such complex environments involving large institutions with complicated data products, with legal implications for any violation. This lack of experience might cause them to be unable to even identify when such violation occur, with real and severe repercussions. Hiring managers now utilize innovative algorithms to help in choosing candidates for employment. These algorithms come to replace professional recruiters and industrial psychologists in the aim of removing human bias from the hiring process. Typical example of human bias in hiring is the like me bias, where people are more inclined to favor people who are similar to them in things like race and gender, but also which college they graduated from and which state they live in. However, as we've shown previously, there is a risk that the human design machine algorithm might incorporate human bias. Choosing the right data to incorporate into the algorithm, aka feature selection, is crucial for creating an unbiased algorithm. Should age and gender be used? In some cultures, boys are seen as more predisposed to technical subjects such as computing, while girls are not encouraged to pursue such things. Using gender as a data point for the algorithm might result in a bias, favoring men over women in hiring engineering roles. Thus, such a seemingly neutral data points might introduce a bias to the hiring algorithm. Hiring algorithm possess a significant challenge from legal perspective. Anti-discrimination laws, such as the Civil Rights Act, strive to protect against discrimination. But if an opaque algorithm decided to hire one candidate over another, how would the rejected candidate know that she was discriminated against? The machine algorithm might not only be opaque for the users of the system, both candidates and hiring manager, but it may very well lack any sort of transparency to its inner working to the data scientist who created it, leaving the bias hidden and impossible to solve. Examples from real life: Amazon, Facebook. This is not just all theoretically stuff, this is all reality. And other examples from Google. In 2018, Algorithm Justice League project published the research on facial recognition technology, which revealed this critical flaw in current software. The title, inspired by Sojourner Truth, Anti-a-Woman, speech delivered in 1851 to the Women's Rights Convention. In the research, they ran more than 1,200 images through numerous large tech companies' facial recognition, software like IBM Watson, Google, Microsoft, and Amazon. They found out that often this type of software can't identify dark-skinned people because dark complexions are underrepresented in the dataset that is used to test the technology. Sojourner Truth was an American women's rights activist. She was born into slavery in New York, but escaped with her infant daughter to freedom in 1826. After going to court to recover her son in 1828, she became the first Black woman to win such a case against a white man. Apparently, that's not good enough for Watson and Google. Ida was an American investigative journalist, educator, and an early leader in the civil rights movement. Microsoft, to add insult to injured, not only did they misclassify Ada, but they had to add this description as well. If you thought that that's only for old picture or black and white photos, no, this is still the case. I had to check that myself to see if this situation. So I tested images of young Kamala Harris, our vice president-elect, and I tested it using Amazon Recognition and Microsoft Computer Vision. Then we can see it is still much likely the case. The nature of data makes it difficult, if not impossible, for the person doing the analysis to separate himself or herself from the data. There are ways, however, to try and maintain objectivity and avoid bias with qualitative data analysis. Use multiple people to code the data. If there is some consistency between your interpretation of that of others, then it is more likely that there is some truth by agreement in your interpretation. Have participants review your results. Ask the people who provided the data whether your interpretation seems to be representative of their beliefs. Verify with more data sources. This is sometimes called triangulation. If you can find other sources of data that support your interpretation, then you can have more confidence that what you found is legitimate. Check for alternative explanations. Consider whether there are other reasons why you obtain your data. If you can rule out or account for alternative explanations, your interpretation will be stronger. And review findings with peers. Ask others to review your conclusions. Sometimes others will see things that you missed or can identify gaps in your arguments that need to be addressed. They can also provide affirmation that your conclusions are sound and reasonable given your data. In 2016, the Executive Office of President Barack Obama issued a report which identifies the opportunities and challenges of big data, the law that protects civil rights and protects against discrimination, and also some best practices for organization in the data industry. The report really highlights the tension between law and technology and the tension between individual rights and organizational rights. The report identified two challenges to promote fairness and overcoming bias. One, the challenge related to the data inputs themselves that are using an algorithm. And two, the design of the algorithm system. For the first challenge can, in fact, result in discrimination. Let's look at some of the best practices suggested from the White House Big Data Report of 2016 to eliminate bias and prevent discrimination.
Neta? Sorry, everyone. I think she's having technical difficulties, but I'm sure she's logging right back in.
I apologize. Zoom crashed on my end. Can blame Zoom.
It's okay. I said she'll be right back.
Thanks for Zoom. So yeah, I kind of left you in the cliffhanger of we were just about to review the best practices of how to avoid bias. Okay, so this quote is directly from the report itself. Moving forward, it is essential that the public and the private sectors continue to have collaborative conversation about how to achieve the most out of the big data technologies, while deliberatively applying these tools to avoid and when appropriate, address discrimination. So best practice 1, the White House suggests supporting research into mitigating algorithm discrimination, building system that supports fairness and accountability, and developing strong data ethics frameworks. The learning about ethics and legal frameworks to prevent discrimination and bias is essential, not only because it's suggested as a best practice, but because we will see as the law does eventually catch up to the technology, those of us who are prepared and understand ethics and legal frameworks will be in a strategic position to do better in this industry. The second best practice suggested by the White House is to encourage market participation to design the best systems, including transparency and accountability mechanisms such as the ability for subjects to correct inaccurate data and to appeal algorithmic-based decisions. So this practice is coming out of what we know to be issues of lack of transparency, the lack of knowledge about what's happening behind the scenes. And it's meant to encourage those that are in the industry to not wait for legal regulatory reform to be enforced upon them, but to take action and to use design practices to address them. The third practice, promoting academic research and industry development of algorithmic auditing and external testing of the big data system to ensure that people are being treated fairly. This is a little bit like the second best practice, but it's about the design system and the importance of continually researching and developing in this area. Let's review questions that we can use to work with data ethics dilemmas in our day-to-day work. Is your data processing based on the fact that you borrow data from the users? Do you ensure that the user's rights are prioritized rather than commercial? Do you ensure that primarily users benefit from their own data, not just the company? Do you use privacy by design principles? And can you describe them clearly? On-device processing, do you ensure that users' data, as far as possible, is processed directly on the user's own device? When processing the data on the server, is collected data not related to an identified person? Do you use profiling? Do you use data to predict individual level behavior or only patterns? Remember, data predictions should only be on patterns, not individuals. Public platforms. Do you have guidelines for using the platform? Do you moderate the platform in order to remove sensitive personal data? If your services are offered to children, do you ensure parental consent? Is data used to develop or train an algorithm? Do you ensure that the use of data does not lead to discrimination? Do you ensure that the use of artificial intelligence or machine learning is the best of the individual and does not cause physical, psychological, social, or financial harm? In which country is your data stored? Where is the storage solutions provided headquarters? Do you use machine learning AI? If so, can you explain the algorithm, the criteria and parameters? Do you use personal data to influence user behavior? Do you ensure that it is transparent when the use of personal data may influence a user's behavior? When do you anonymize personal data? Do you use end-to-end encryption of data? Do you minimize the use of metadata and explain how it is done? Do you sell to third parties? Do you sell data as a personal identifiable data? Do you sell data as patterns on an aggregated level? If you sell data, are you making sure that it is fully anonymized information, only describing patterns, not individuals? Do you use third-party cookies? Does this include social media cookies and social media logins? If you use third-party cookies, are your users fully aware that your cookie use leads to sharing of data about your users and with third parties? And do they agree with that? And that's it. Thank you, everyone, for your time. I hope I was able to spark new ideas and methods so together we can fight the battle and get some ethics into data. And to all of those who have served and those who continue to serve, happy Veterans Day and thank you for your service. Any questions?
I do have one question that came through. What do you think about the going? Sorry, now there's some more coming. Sorry. What do you think what do you think about the ongoing court cases in U.S. on responsibilities due to Tesla driverless algorithm?
Okay, so I think that's a really good example. As we saw the MIT research in 2018, now we can actually see how all of this come into play with Tesla releasing more and more driverless vehicle and stuff like that. And there are many, I want to say amusing videos about that. Like, for example, the car recognize McDonald's sign and thinks that's something else, or how easy it is to manipulate the car's cameras and machine learning behind it by just, describing on traffic signs and stuff like that. So we're not there, not quite yet. I think that as a society, we want to believe that AI is over there, but we're not that quite yet. And it's going to take a while, and we should be patient to it.
Yeah. It looks like there's another one. What are the future trends in applied AI that you feel will run the risk of the most bias?
Okay, and so I think that we can see several trends right now, for example, that can be anything that use personal information. So let's say that 5 years ago, we would not have face recognition available as we have today, and not even fingerprinting, but now we have it everywhere. If we want to use our smartphone, or some people even use that to get inside their homes, if they're using the Ring, for example. So we're going to see a lot of that, and that can be easily misused by evil organizations.
I think you answered this next one. Do you have any other ideas? What should we be wary of when it comes to future AI applications?
Okay, I'm assuming that most of the audience is data scientists. So we as data scientists, we are the last defense line of data. Okay, we already got the data from the data team, and we know which algorithm we need to build, and we need to be aware of the outcome of our algorithm. And we should keep into mind that we have data, it's a sensitive data, and not just, oh, this is the data, let's push it to the algorithm. Oh, the accuracy, the IOC rate is 90%, awesome, job is done. We need to think. We as a data scientist, we are critical thinkers, and it's not an easy job, I know, but it's a battle between ourselves of not, oh, the algorithm is working, I don't care the criteria or parameters. I need to make sure that the algorithm, won't affect any people, because even if we are a data scientist, we are also customers of bank or healthcare or any other industry, and we don't want any other algorithm to misjudge us because another data scientist was lazy.
All right, here's another one. What are the typical techniques to determine if algorithms resulting in bias before go to market and already in market? How much of the difficulty in the facial recognition software due to the quality of the camera, sensors, and images versus the set of training images?
Okay, 2 questions. Let's start with the first one. So as I said, we have to analyze the machine learning algorithm. We can't just look at the accuracy or F1 score. We need to look at feature importance. Now, in the recent years, this has become a challenge because deep learning. If in the old machine learning or traditional machine learning, you would have seen a decision tree or regression, so we can see the formula, we can see the variables, and we can see the weight. Now with neural networks, it's become more of a challenge, but there is an option to see all of the nets and the weights and the feature importance inside neural network. an easy way to do it, some kind of a brute force against the algorithm, which is a time and resource consuming. I'm just saying that before saying what it is, keep that in mind. But that can be removing a feature and try to rebuild the model and see the impact that feature has on the model, on the accuracy. Now we know if each feature is, a proxy for any bias. For example, another option would be to randomize each of the feature values and see the impact of the model. This is more of kind of a safe approach because it's quicker to randomize and run the training rather than to do some kind of a brute force of removing and adding back the features. The second question about facial recognition, the quality of the cameras, I believe. Yeah, okay. Yes, this is the quality of the camera. So I see it being into play in two ways. One, we have the model. The model has been trained on statistically training data. I assume we're talking about supervised machine learning. So the quality of the images being used in the training is really important because Amazon, just taking Amazon as an example because of Ring, they might have used, 4K images, but if at the day-to-day, most people have a basic camera, then that would be some kind of misfit between the resolution of my camera and the resolution that was trained in the algorithm. And that might result in a difference that, if I'm sending my image to get a prediction or classification to the algorithm, and the algorithm was trained of more cleared images, I might get bad results. So it's really important to make sure that, if we're saying the quality of the camera, I don't know if you noticed, but on the Kamala Harris images, Amazon actually tagged, besides Kamala being a man, they also said that she has sunglasses because there was some dark shade in her eyes. So this is just an example of bad quality image, and the algorithm, he was trained with some kind of picture with sunglasses. So yeah, this is a sunglasses from the algorithm perspective.
It's crazy. All right, we have another one. How complex is it for fixed bias algorithms? Do you know if any of the companies are trying to correct current biases?
Okay. How hard it is, that depends. We need to identify that we have a problem, which is, I would say, 90% of the challenge. But let's assume that we identify a problem, then we need to work on that. A simple solution would be to remove the problematic feature, but that may harm the accuracy of the algorithm. And now there is a conflict between the business, who cares about the ROI and the business value, and we want to get the best accuracy as possible. And on the other hand, we have our conscience. We want to be an ethical person. We don't want to use intentionally an algorithm with a bias. So usually what people do is that, we have the algorithm and then we can try to build another algorithm. So for example, let's say that we have a random forest and now we're beating logistic regression. And hopefully they find another algorithm which not using the problematic feature. I do know that recently, at least in the last year, we've met with at least 3 companies from the finance vertical and also from the healthcare vertical that are starting to think about it. And they wanted to analyze their machine learning algorithm to make sure that they are not biased by any means. So I think that there is more public awareness for that, but I still think that at the end of the day, it's going to be a battle between the business and the ROI, and how much is it important if our algorithm is biased. It seems that for now, it's a tight battle, but hopefully in the future, it would be more acceptable to, yes, we would live with less, 5% accuracy, but we can sleep at night that our algorithm is not discriminating or have any bias at all.
Great answers. I think that is it for the nope, there's another one. As soon as I say that. When is it ethical to openly take into account features like race, gender, etc., to operate in an affirmative action mode to attempt to give more opportunities?
Okay, I would say that this is this is defined by the use case. Okay, so one example that pops into my mind is healthcare. And again, not all healthcare use cases. But for example, we know that African Americans, they have different healthcare problems around heart attack than white people. So in this case, I do not want to aggregate people as a whole without the gender if we know, if there is medical proof or research that we know that we need to take into account the race, for example.
That is it for the moment.
Going once.
Yeah.
Going twice.
Yep. It looks like that is all for the minute. Okay. Oh, here's one more. What types of ways to visualize how algorithms boring working? Am I reading that right? What types of ways to visualize how algorithms boring working?
So yeah, I think the typo was, it is boring to view how the algorithm is working. But again, it depends which kind of an algorithm we're using. The more traditional machine learning, so let's say we're using logistic regression, then it's easy. We can see the acquisition. We can see which variable, let's say the age and gender and income, and you can see the weight each variable is getting for the machine learning. But nowadays, with deep learning and neural networks being more and more available due to the low cost of the computing resources, it's getting tougher to see that. Deep learning, the name deep learning is not because it's deep on the theoretical level. It's because we have many, many nets, layers of neural network and nets connecting between them. And then there is not just an easy button of show me the algorithm or show me the decision tree or how you got to this decision. And then we need to really, really dig in and start to see on each layer of network, what are the input parameters and what is the weight each one of them is getting. And it is not trivial. Some libraries do offer the option to see the feature importance, at least to some degree. We would not see the weight in that case, but we would at least see which kind of features are coming into hand while running the algorithm. So it is a start.
All right. Every time I say that's it, there's another one. But these are great questions and great answers. I feel like I've learned so much just by sitting here. All right. Well, if there's no takers, we'll give them one more minute. All right. Well, we will let everyone get back to their busy, beautiful days. Hopefully be able to enjoy the weather one last moment before getting back to work. But thank you so much, Neta. This was awesome, super helpful. I didn't even think about some of the ways that it's being used. So it's really interesting.
Thank you. Thank you for having me.
Awesome. Well, thank you so much. Cheers. That's what we're getting. Thank you. Bye.